Alright, welcome to part 2 of the video. Again, we're looking at the y component now of this particular vector right here. So we're looking at this side over here, which according to our angle is the opposite, and we know the hypotenuse. We're going to be using the sine to solve for that. So if you look, sine of our angle, which is 30 degrees, is equal to the opposite, which is y, divided by the hypotenuse, which is 90 meters per second. We're going to solve for y by multiplying both sides by 90 to give us this right here. So then y is equal to, again, if we plug it into our calculator, I believe it's 45. If I hit sine of 30, so I just change one thing on my calculator, change the cosine to sine, and I get 45 meters per second. And we're not going to forget our direction on this one. Which direction is that pointing to get to here? So from here to here, it looks like it's north. And that's how we break it into components. So, the skills we've looked at so far, we've looked at adding vectors in the same direction, subtracting vectors that are in opposite directions, and then if we have a vector at an angle, we can break it into x and y components. Well, why would we want to do that? Well, let's look at the next one. We're going to have multiple vectors now in this next one, and we need to break them all into component vectors in x and y so that we can add and subtract them together to get one x and one y vector to find the final resultant. So, what? That's okay. If you're confused at this point, hopefully we'll eliminate that confusion here in just a minute. So let's look at this problem that we have next. We are on a camping trip. We're taking a hike in the woods. We have a compass, so we know where we are so we don't get lost. So let's look at where we're walking. We're walking 100.0 meters north. .70 meters at 30 degrees east of south. So east of the south axis. So I'm going to draw another, I'm just going to draw them all in the same coordinate system, tail to tail. So east of south, that would be right here. 30 degrees, and it's 70 meters. I then have 85 meters, 15 degrees south of west. 85 meters. What is the resultant vector of this situation? Okay, and then if I did that, if I actually walked here, then went here, and then went, here, that's actually what I'm doing. Going north, back this direction, back over here. But in relation to my campsite, if this were my campsite, I'm trying to determine that vector where I'm at in relation to that campsite. So at some angle, some vector that's off in this direction, possibly, depends, I didn't draw these to scale, nor did I check my angles, but if I were to do it graphically, this would be my 30 degrees, and if I did this one here, this should be my 15 degrees off of there. But that's, you could do it, you could take a ruler, you could take a protractor, and you could figure that all out and do it graphically and find your angle, but we're going to do it mathematically. So the first thing that I want to do, if I look up above, is draw all the vectors in a graph tail to tail. Done. For a multiple vector system, break all vectors into horizontal and vertical components. So this one only has a vertical component, so that one's easy. And then these two I need to break into horizontal and vertical components. So I'm going to number my vectors just so it's easy for me. 1, 2, and 3. I'm going to set up a grid system. So I have an X and a Y. Separate those out. Separate those out. And I'll show you kind of the expanded view of what I'm doing. And then I'm going to start working my way through. So that's what the third bullet point says. It says place components onto a table of horizontal and vertical components. Horizontal, vertical. Let's look at number 1. Are there any horizontals on number 1? No. Doesn't apply. Verticals, yes. 100.0 meters direction, north. Move on. Number 2. So I need to break this into components. I'm going to zoom in so you can see this. Fix my focus here. This, if I make this a right triangle with this angle, I can make a vertical component and a horizontal component. Does everybody see that? How I make that into a triangle? And here's my right triangle. This would be my x component, and this would be my y component for that particular one. I know the hypotenuse, and I'm looking for the x, and I know the angle. What trig function do I use? It's the opposite side and hypotenuse. Good. Sine. So I go back to my x component here. Sine of 30 degrees is equal to the opposite, which is x, over the hypotenuse, which is 70 meters. Solve for x. X is equal to 70 meters times the sine of 30 degrees. Plug it in my calculator. I get 35 meters. Again, looking at digits, 2, 2, answer has 2. Give it a direction. Which way is that going? East. The y component is very simple to do. Once you've done the x, the y is cakewalk. This is just now using the cosine of 30. Everything else is the same. And that should make sense, because if you look at my diagram right here, the y is just the adjacent side of that angle, and the adjacent side uses cosine, adjacent over hypotenuse. So if this one used sine, I use cosine here. If it used cosine in the x, I use sine in the y. Again, multiply, plug it back in my calculator. All I have to do is go back. So again, if you look at my calculator, I just go back to where it says sine there, hit the cosine button so it changes it, hit equals again, and I get 60.62. Now, here I should have 2 digits, but because this is not what I'm really looking for, I'm going to carry some extra digits and underline them. This is kind of the first time that I've done that. These here, this came exactly 35. This is not. So if I rounded this number to 61, which I should, but then use it in a calculation later on, I'm going to get round off error. So I'm going to keep some extra digits and underline them so I know that they're not significant. But I don't want to round them off, or it's going to make my error multiply later on. This direction is south. One more to go. Number 3. Again, make your right triangle. See that? I made a right triangle now out of that, using that angle right there for angle 3. So what side is this? Good. X. And what side would this be? Good. It's your y side. So let's start with number 3. Let's look at the x side again first. What side of your right triangle is x? Here's the angle. That would be the adjacent. Excellent. What trig function are we going to use if we're looking for adjacent and hypotenuse? Cosine. Cosine of 15 degrees is equal to the adjacent, x, over the hypotenuse, 85 meters. X is 85 meters times the cosine of 15 degrees. X equals 82.10 meters. Direction, west. Again, with that, I don't even have to think for the y. If I use cosine in the x, what do I have to use here? Again, back in my calculator, back up, hit the sine button, 21.9996. So actually that's going to round to 22.00. In meters. Direction, it's pointing south to get to that head there. So now what I have is I have a chart filled out with a bunch of x and y coordinates, or vectors. And now what I can do is I can simplify these to one x and one y by adding them up. So if this is east and this one's west, do I sum them or take the difference? Pointing in opposite directions. Take the difference. So what I'm going to do is I'm going to look and I'm going to say, okay, the west one's bigger than the east, so I'm going to take west minus east. So 82.10 minus 35, I get 47.10 meters, and I'm still going west because it won out. How about north and south? Well, these two are in the south, and I can see that 60 plus 22 is going to be less than 100. I'm going to take my north minus my south minus my south. 100 minus 60.61 minus 22. I get 17.39 meters north. So this is what my chart looks like. Am I done? No, I'm not done. Sorry, this is a big problem. So I have two component vectors now that I want to find the resultant for. So I'm going to go 47 meters west, and I'm going to go 17 meters north. How'd we do it? We made our rectangle. Finding the resultant here. Magnitude. Pythagorean theorem. R equals the square root of a squared plus b squared. So this would be our resultant value there. So we're going to square both these numbers and then take the square root. 47.10 meters squared plus 17.39 meters squared. Again, I can do this all in my calculator. I already have my 17.39 in my calculator. I'm just going to hit my squared button, plus 47.10 squared equals square root of my answer, and I get 50.21. Again, I'm only going to keep two digits, so it's going to actually round to 50 meters. Again, I looked at two digits. I'm letting you cheat a little bit on that addition rule. And then at what angle are we going to choose? Well, if I look at this, I'm going to just pick this angle right here. So what is my opposite side? It would be this, and this would be my adjacent. So I need to find the tangent of my angle. This is going to be opposite, which is 17.39 meters, divided by my adjacent of 47.10 meters. I'm taking the inverse tangent of that value. Again, I can use an arrow. I'm okay with arrows, so you don't have to rewrite all those numbers again. On your calculator, 17.39 divided by 47.10, inverse tangent. I get 20.26. I run that to 20 degrees. In which way? So I have 20 degrees, and then I am what of what? Well, here's your coordinate system. Looks like it's north of the west axis. North of west. This would then be my final answer. Hope that makes sense. Hope that's a good review for you to help you with the problems that you're going to have in this. Have a good day.